Hey guys, good evening, all of you. Can you hear me?
Hello, good evening.
Good evening, sir.
Hey, good evening, buddy.
How are you, sir?
Good. Spanning tree. Just open. Okay. Something called a spanning tree. So, guys, in the last classes, we have done with the concept of the spanning tree protocol, right? So, okay, please check the input and use not allowed to. Okay, check your input use only allow the character. Okay, test one. Right, and test one. So give the simple topology of the test one, right? So I'll do one thing, better to write in the notepad. So switch one has a connectivity with the 0/0 to the switch 2 0/0. Switch one has 0/1, switch 3 has 0/0. 1 minute, guys. And switch 3 0/1 has a connectivity with the what I call switch 1 not. It's always 2 0/1, right? So let me copy this one, put it over there and add it. And also the switch one, the name should be this guy, switch two, switch three. And we have a iOS I can go for. This will be awesome, right? Yes. And done. And this has to be switch and all goods. Let me save this one. So today we are only going to discuss about only one thing that we have done in the last classes, like how we can find which one is a root bridge, sorry, which one is a root, of course, root bridge and DP and RP ports, right? All those things. Right? So this is my topology. And I'll do one thing. Save this one. Let me start my devices and change the port size because I think so it's already 14 here around. I'll make this guy as a 9 is better. Save it and take a screenshot. And I'll put it in the print file. So guys, here we have a topology. I'll write on the MAC address of this guy. So I'm not going to write on the complete MAC address, yes, but the last 4 bits, not 4 bit, 4 digit. This guy should be 200, the MAC address of this guy, and this guy should be 300, right? So in this case, what happened? This guy will become the root bridge, as we know that. Okay, and I think so. Let me check the cost of this link. What the cost is happening? Switch one, switch two, and switch three, right? So switch one, I'll say that no, yes, yes, no, yes, yes, and yes, yes. Perfect. And this is good. So if you have a look on the switch one, right? So spanning tree, by default spanning tree is enabled, right? You don't need to enable this thing. If you want to disable this guy, you have to just go in the config terminal mode and say that no spanning tree and define for the particular VLAN number one. Because a spanning tree is run for the VLAN, right? Depends on the VLAN, how many VLANs you have. For example, I want to enable, listen to me, I want to enable the spanning tree protocol, right? I want to enable the spanning tree protocol only for the VLAN number 10, not for the 20, you can do that. But by default is what? By default, spanning tree protocol is enabled for all VLANs. And this is the recommendation. Okay, yeah, it's not like, you can disable it, but it's never recommendation to disable it. It's up to you. You can manipulate those things, but it never recommendation to manipulate the spanning tree protocol, right? The things, because If by chance, right, if something wrong happened, then you have a flooding in your network, right? A broadcast flooding in your network, and that caused the hit on the CPU as well as, right. That's not a good for the CPU health of the switches as well as. So it's not recommendation to disable it. Okay, if you want, you can. Like if somebody will ask you, can we disable this span tree protocol? Yes, we can disable it. You just need to put the VLAN number one and define the what VLAN you want to disable this. So leave it right now the default behavior, and if you see the source tree by default, this protocol is enabled and introduced in the 1984, right? And if you see what's the MAC address of this guy is 100, right? 0 100. This should be 0200. This should be 0300. So of course, this will become the root bridge, right? And here we have so this all this guy will become the non-root bridge, an RB and an RB. Just for a quick info, I'll let you know one thing. I can write uh, in a different way. Okay, so all the ports of root bridge will become DP. You will have one DP on each segment, right? RP is always towards the root bridge, right? And what we call now, RP is always present on every non-root bridge, right? Always. And you will have a only one RP on single non-root bridge. So these are the things that you have to always remember one thing. So you will not find the DP DP. This will be right, the segment on a both the link, right? You will not find the DP and DP, never. It will be a result will be a loop, right? Never you will find like this. This is the wrong one. I'll just give you the summary, right? And you will have a DP. Either you will have a RP or either you will have a blocking one. RP and blocking कभी नहीं मिलेगा तुमको. And RP भी नहीं होगा. So guys, so all the ports of the root will become the DP. So this interface will be the DP now. This interface also will be DP, right? What is the cost is of this particular link right now? 100. So I will just say the 100 over there, and 100 on this guy, and 100 on this guy, right? So try to understand lower cost to the root bridge, right? Lower cost to the root bridge will become the RP port. RP, right? So this guy will become the RP, right? And this guy will become the RP. All good? Of course, right? I can, if this person will take example, if this person will go by a like this, the cost is 100, and if this person will go by like this, the cost is 200, right? So lower cost to the root bridge will become the RPO. So this is the RP, right? Same way from this side. What happens if I go from the this link, right? The cost will be 100, and if I go like this, the cost will be 200, right? So this guy will be the RP. What about this guy now? If I go from this way, right, the cost is 200 to the root bridge, and if I go from this way, the cost is 200 again. So if the cost will be tie, right? If cost tie, then it will look up for lower sender bridge ID. So who has the loads? Of course, if this guy is sending the own BPDU to this guy, right, and he's also sending the own BPDU to this guy, and this is the configuration BPDU, if you remember that. So in this configuration BPDU, what is the root center root bridge ID? So center root bridge ID of this guy will be 0200, of course, right? And this guy will be 0300. That's the MAC address of this person, right? So who has a lower one? This one, right? So this interface will become the DP or this interface will go in the blocking state. So how will you like the how like your logical topology will look like this one switch one, you have a switch two, and we have a switch three like this we have a lot. This is the logical topology we look at, right? Let's verify this all those things. If you go back to the switch one and you can see all my this ports are DP, right? And this is my same own information. You can see that this is the root bridge. So this is the switch one. And what is the MAC address of this guy? So this information is talk about the root bridge information, and this information is talk about the my own information. So of course I'm the root bridge, so the same MAC address is there. If you come back to the switch 2 now, if you see the switch 2 enable so spanning tree, right? Let me define the host name of this guy. Host name switch 2. You can have a look. So what switch 2 is saying that hey, this guy is the root bridge. According to the switch 2, he is the root bridge, right? And this is my own information. And what this guy is telling, hey, my this interface is 0/0 is a root port, and my this interface is 0/1 is a DP, right? Same thing if you have a look right on the switch 3. What this guy is telling you, hey, according to me, this guy is the root bridge. According to me, I'm present over there. According to me, he's the root bridge. And this is my own information, 0300. And my this interface is 0/0 is a root port. And my this interface is a blocking state. We have seen in the last classes, we have a 5 states of the spanning tree protocol. One, we have a disable, where the spanning tree is actually not running. Then we have a, we can call as a blocking state. The for a few milliseconds, what happened, your interface will move, we can say that go through the blocking state. Just have a look the is there any loop or not. Then it will go for the listening state. In the listening state they will spend the 15 second, and then it will go for the learning state. In the learning state they will spend the 15 second, and then now it will move in the forwarding state, right? Total we have a 30 second. In the listening second, I'm going to make all the election of the port like a DP, RP, and whatever the ports will become the blocking, it will move in the blocking state. In the learning state, what I can do over there, I'm going to learn the MAC address, right? And the forwarding, you can forward your data traffic. So we have already covered this part, right? All these states already we have seen in the last classes. So hope this thing is clear to all of you, like how this election is coming. Let's do the different topology now. I'll do one thing. I'll make some little bit more complicated. So test two. Okay, test two. And here we have, I can make it, this should be, so 1 0/0, 2 0/0, 1 0/0, then 3 0/0, then come on, 3 0/1, 4 0/0, and 2 0/1, 4 0/1. I think so this is the square one. Which one? Awesome. And here we have save it and test two. I think so. Let me design one. So should be switch to should be there. Switch 1 should be there, and switch 3 should be there, like the square one, right? And switch 4 should be there. All good, right? Save this one and let me start the devices. And here we have. And nobody will ask this kind of like, they will give you the topology in these days. That's like, no, in the pandemic situation, they're asking the question on the phone call and making a video call on the right. They will not ask this kind of question like, hey, tell me which one will be the DP and RP and this kind of things. But yeah, just for your knowledge. So now we have a second one topology, right? So we can see that this is the MAC at the same one, like we have a 100 one, 0, 100, 0, 200, 0, 400, and 0, 300. Again, so of course, this should be a root bridge, as we know that this should be a non-root bridge. This should be non-root bridge, and this should be non-root bridge, right? All good. So now, of course, all the interface of the root bridge will become the DP, right? So this interface, I can declare this, hey, you are the DP as well as you are the DP, right? The cost is 100. The cost is 100, right? I'm not teaching you anything new that we have already seen each and every part in the last class, right? Don't worry, I'll go through that, right? The all the costing. So I'm making this all this stuff right now. The make this all stuff right here cost. Okay, the port ID concept, right? The BPDU packet structure, right? TCN BPDU, right? We can say that manipulations things, right? The spanning tree manipulations, all those things we can right now put this all this thing in the packing right now. We'll see each and everything. We are just trying to understand how the election is happening. That's it. So if I talk about how many things we have done in the last classes, we have just two classes of the spanning tree. We have just done how the what is loop, what are the different types of loop we have in the networking, what are the mechanism we are using to prevent the loop, whatever the states of the spanning tree, and how the election is happening. That's it, nothing else. So this will be the DP, and of course, this will be again, if this person will go through from here to here, the cost is 100, and if this person will go through the here to here, the cost is what 300, right? So again, what happened? This guy will become the RP, right? Same way now, it's an example from this side. If this guy source 3 will go through the here, and if it go via this guy, the cost is 300 and cost is 100. So again, this interface will become the what? RP. All cool. Switch 4 perspective, right? I will go through the like this way and like this way as well as cost is tied, right? If the cost will be tied, they need to look up for the load center residing. So who has a load center residing? Of course, he's sending the the BPDU with the MAC address is what 200, and he's saying the BPDU with the MAC address is what 300. So who has a lower center residing? This guy, right? So this interface will go in the which state? DP or blocking. This interface, right? Here the lower center bridge ID, lower center bridge ID, and here will be higher center bridge ID. So which one will become this segment, right? If I talk about this segment and this segment, who will go for the blocking your state? And who will become the RP? Yep, tell me.
Switch force E0/0 will go to blocking,
Okay,
and
perfect,
E01 will go to root port.
awesome. So this would be in the blocking, and this would be in the RP, and all the remaining these guys will be of course DP, right? Because I mentioned that the RP is what? Every non-root bridge. So this is the non-bridge. You will have one RP over there. You will have one RP over there. You will have one RP over there. So every non-root bridge. Other things was what? Other thing was RP is always towards the root bridge, right? So towards the root bridge, towards the root bridge. It will never become the RP, right? It's not towards the root bridge, it's towards the non-root bridge. So now if you verify all those things, let's do one thing. Let me start my devices. I already started switch one. And I said the no, yes, yes. Switch two, no, yes. Switch three, no, yes. Switch four, no, yes. And here we have this. So if you have a, let's start from the switch one now. Switch one, of course, you are the root bridge. So let me change the host name switch one, do the root. So it's time free. You can see that this is the guy is a root bridge, right? That's this person. And wait for some time. Come on. Why they moving the dispute state, man? Uh-oh, 1 minute. Time free mode. Previously enable host name system. Time free mode previously and see this configuration as last as 4. Spanning host name sys 3. PSH 4. Spanning mode previously and see this configuration and enable string spanning tree sys 3. Spanning mode previously one this configuration. Oh, screen. We'll go through the listening and loading state, right? Wait for some time. All good, awesome. So this is the root bridge now. The same MAC address 100, and all this interface we have in the forwarding state, right? And if you go back to the switch to now, this guy, do switch time free. So you can see that according to the switch to here saying, hey, this is the guy is the root bridge, right? The 100 one. And my this is the 200, that's the MAC address, non-root bridge. And according to me, this interface E0/0 is the RP port. And this interface E0/1 is a designated port, right? All good. At the same time, if you have a close look on the switch 3, switch line 3, and according to me as well as he's saying, hey, he's the root bridge 100, and this is my own information 300, and R it's 0/0 is the RP port, right? Come on, now this thing is happening. Okay, it should not be there, right? 1 minute. This should not be there. This is the wrong output that is giving. 1 minute. Let me do one more time. So spine free enable and
Sir, what is the priority number? So 128.1, 128.2.
we'll discuss that things later on. We haven't come to this point right now.
Okay,
We
sir.
just put this thing in the parking state right now. Okay, 1 minute, guys. This is not a correct output. Let me restart my device because sometimes it will not give you the proper output. So I'll do one thing. Restart my devices because DP in DP never will be there. It will always create a loop. My mapping is correct, right? It's 0/0 0. Oh, that's why my mapping is wrong, guys. 1 minute. That's why this problem is happening. My mapping is wrong. 1 minute. There's two. So mapping is 0/0 2/0, and it's 1/0. It should be E0/1 there, right? And it should be E3 0/0 30/1 4/0/0 and 2/1. Yeah, now it's correct, right? So mapping is awesome. So let me start it and didn't try around. I'll delete that one. And first of all, I deleted this one information, right? Or why should I delete it? I just changed the name, right? This is the E0/0 and 0/1. This is the E0/1, guys. Is one is there. Okay. So now if you have a look, so it's three. Can you see that now it's correct, right? E0/0 is the DRP port and E0/1 is the DP port. Okay, and according to Sys 3 as class, he's the guy, right? He's the root bridge. And this is my own information. And even if you go for the switch for now, according to the switch, but that's the most important, right? You know, the output is there. So it's 9-3. According to the switchboard, still this guy's on, you know, the root bridge. Hey, you are the root bridge. And my own information is a 400. That's my own information. And according to me, this E0/ should be on the RP port, right? And this is how the RP port, right? And this should be in the blocking state. And if you have a look, guys, one thing that I told you that if you remember the theory day that the states we have discussed, if you have a look, 1 minute I'll show you this part as well as. So, and we have book, CCNP. And over here we have spectrum. So if you have a first glance over there, the blocking port is what is single. The blocking state, the port cannot receive or transmit the data traffic, but I can not add the MAC address in the MAC address table. Instead, a port is allowed to receive only BPD. I can receive the BPD. That I do have ability. This is sometimes they will ask you in the interview, right? Hey, tell me what are the difference between the states, right, or the span grid. So if you have a look at the blocking port, right, if I'm going to switch 4 right now, and it's a blocking E0/0, so it's spanning free, right? And what I call Ethernet 0/1, right? Interface is 0/0, and have all the detailed information, right? I am able to receive the BPD 106 109, 1010. So can you see 106 previously, then 109 and 110. I'm not sending, right? Sending is still one. This was the send one when the election was happening. The election was happened that time. This sending was there, right? I'm only going to receive it. So this guy is sending the BPD and he's receiving. All good. Now let's go for the next topology. I can change with the something, make some special and manage laboratories, test 3. And here we have this guy. Come on. So it should be 2 0/0, 0/1, and I'll make something like 1 0/2 with the 4 0/2. Awesome, right? A line in between the rectangle. So it's 4, right? So it's 2 should be there, and so it's 3 should be there. One should be there. Done, and here we have this topology. So I have already started. So switch 1, switch 2, switch 3, switch 4. Now 0 100, 0 200, 0 300, and 0 400. This is the last 4 digit of MAC address. So of course this will be the root bridge. As we know, this is the non-root bridge. This also will be non-root bridge. This also will be non-root bridge. Now tell me, DP, DP, DP. Now guys, according to the system, the cost I'll just write on. The cost is 100 now. The cost is 100. The cost is 100. I'll just show you the default behavior right now. We'll see that what happens if I'm going to manipulate the cost. We'll see that later on. Okay. Understand the basic one, then we'll see the manipulation as well as. Just put the manipulation and all those higher level things in the parking. We'll see that later on. Yep. Tell me, according to the system, right, who will become the RP? According to the sys2, who will become the RP?
E0/0.
And sys3,
E0/0.
switch 4.
E0/2.
Okay.
Yes.
Blocking.
E0/0.
Awesome. And this will be
Blocking.
so this will be DP, this will be DP, and none, right? Yep. Out. Switch 1. No, yes. You can have a multiple block force, right? This is spine tree. Let me check which protocol is going to. Why this thing is happening? Spine tree. I was specifying over previous right. Host name. This one. Use the spine tree. All done. Root bridge. Right. DB. System. According to the system, is the root bridge. And mine is 200. Mine ports RPDP. Come back to the switch 3 now. According to switch 3, he is also saying that hey, this is the root bridge, and my information is 300, and my ports are root port, this interface, and mine is a DP, this interface. All good. Switch 4 now. Have a look. E0/2 RP and remaining out blocking. And here is done. All good. Now let's add something more. What I can do now. Manage and laboratories, and I'll make a test for. I'll try to make a test 6 as well as test 4 this is. And oh, come on. And we'll make this guy now like this. Okay. Something called, not this one. Make this guy as well like this, right? The fourth double line between the 2 0/2 now and 3 0/2. Then we'll add the double links. So do a little bit, go the baby step is always good, right? Don't jump, follow the baby step. Baby step always helps to resolve the each and every steps. Sorry, problems. Okay. So, and this will be six. Switch one, switch two, switch three, switch. You have it. Come on. 0200, 0300, 0400, right? This will be RB. This will be non-root bridge. This will be RB. Sorry, non-root bridge, and this will be non-root bridge. First is 100. 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 So of course, this will be DP. This will be DP. This will be DP, right? This will be RP, and this will be RP. Now make a list. That you already know that I made it. Now tell me. About the switch 2. Tell me about the switch 2. Switch 2 has done. Tell me about the switch 4, sorry. Because I have done with the root port. So you will only have a one root port, right? Only one RP on non-root bridge. So we have done with the switch 3 non-root bridge, one RP I have done over there. Make the switch 4. Who will be RP?
E0 by 2 will be the RP.
E0 by 2 will be the RP. Now find the blocking one.
E0 by 1 and E0 by 0 will be in blocking state.
E0 by 0 and E0 by 1 will in the blocking. And about the switch 3 and switch 2?
E0 by 2 is blocking.
Which one? Switch 3, switch 2?
Switch 3.
Switch 3?
Yeah.
And this will be?
Designated.
DP.
तो इस लाइन पे ये भी डीपी होता है, इस लाइन पे डीपी। माइक ऑन है और मूवी अच्छी चल रही है, ये पता नहीं है ना, ये महाभारत चल रही है, बंद कर ले। Switch 1 host name, switch 1 spanning tree mode previously to save this configuration. Switch 3 enable host name, spanning tree mode previously. Spanning tree mode previously. Save host name switch 1. All right. So here we have, guys, so let's go on switch 1 and okay, I have already over there, so switch 1. Have a look. Do switch spine tree. According to me, I'm the guy who is the king in this topology, and my all the ports of the designated port. This information is talking about the root bridge. This information is talking about the bridge ID. Switch to now, according to the switch to, let's see who is the root bridge, right? Do switch spine tree code. Sorry, do switch spine tree. According to me, switch to saying that hey, this is the root bridge. That's same person is saying that hey, this is the root bridge, and my this is the own information 200. And according to me, this guy is the root port E0/0. All perfect. E0/2 and E0/1 will be DP. Awesome. Switch 3 now. Do switch spine 3. So this is my own information 300. According to me, this guy is a root bridge, and my RP is a E0/0. E0/1 is a DP, and E0/2 is a blocking. Same thing if you have a look on our switch 4 now. Do switch spine 3. According to the switch 4, he is the root bridge. My own information, and according to me, My E0/2 will be a root port, that is this guy, and all these guys too will be a blocking, right? Done. Up. Now hope these two steps are clear, right? If the cost tie, then if we look up for the lower center residing. Now let's go for the little bit more detail. I'm just going to change my topology with something little bit more critical. Not so much, but yeah, but little bit. That you have to find the okay. Test number 5. All good. And here we have to change the thing. So I'll go on a switch 2. I'll make this guy 0/3 as well as 3 0/3, and switch 1 I'm going to make the 0/3 as well as switch 4 0/3 double ports, and that will introduce the new steps. All done. Awesome. Oh, yep. ठीक है, little good. यहाँ पे तुमको कुछ नया मिलेगा. Come on. Hundred, 0, 100. Of course, this will be a root bridge. This will be non-root bridge. Yes, go on. Tell me what happened. And the cost is already 100, right, on Abril. You already know this thing, right? So I'm just right on now, guys. Come and sit. DP, 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 RP, RP. बताओ स्विच फोर पे आरपी कौन बनेगा?
E0 by 2.
E0.
If cost is tight, then lower center presiding. If lower center presiding tight, then lower center portile. Me, na? So according to the switch for each 0/2 will be RP. पता भाई blocking कौन सा होगा? तो blocking हो जाएगा. All those three
0.
guys.
All three will be in block state.
Block and block. Switch 2. This will be DP. This one.
In designated E0 by 2 and E0 by 3 will be designated.
E0/2 and E0/3 will be designated DP and DP. like this,
Yes.
and switch 3 blocking.
Yeah. E0 by 2 and E0 by 3 will be in blocking state.
Done. Okay, quick info. Now, guys, have a look the switch one now. The switch one information. So it's spanning tree, host name, switch one, and spanning tree mode previously. Do the save this configuration switch two as class switch three, host name switch three, and spanning tree mode previous state, right? And we will save this configuration switch four now. Enable host name will be switch four, spanning tree mode previously. And here done. Switch three, switch two now. Host name will be switch two, and spanning tree mode previously. Now done. And here we are. So it's span free, and this states is moving through the learning state. Wait for some more time. अच्छा एक टास्क देता हूँ कल है ना कल क्या ना कल नहीं you have a complete this weekend right 4 5 days guys today is Monday so you have a complete weekend you have entire weekend you have right YouTube पे जाना just go on the YouTube and search the networking Uber nets something called like that आगे से उसको भी डाल देना जब मन करेगा पर क्या ना क्या होता है ठीक है पर क्या ना क्या होता है 1 घंटे का कोई वीडियो मिल जाएगा देख लेना समझ में आ जाएगा क्या होता है एक बार में समझ में नहीं आया 2 बार देखना 2 बार में 3 बार देखना ठीक है चलो so span free and here we have guys this is the root reach now with this signal and all this port is a dp right so this is the root reach and if you come back to the switch to now do so span free and here we have on a switch 2 this guy is the according to the switch 2 he's saying that hey this guy is the root reach 100 and my own information is 200 and according to me the root port is 0 slash is the root port and the rest of the port will be dp so you will have a multiple designated port on a non-root bridge but you will have a single root port on a non-root bridge if you same thing have a look on a switch 3 now do so spine 3 and you can see according to me as well as he's saying that hey let's listen to me according to me the switch 100 is the root bridge and my own information is 300 right and if I talk about the port roles so port roles will be e0 slash 0 is the rp right e0 slash 1 that's my dp and the remaining 2 ports are the alternate blocking state okay the reason was lower port sender port id this guy's a higher sender port id right this guy's a lower one and if you come back to the switch port now do so spine free again same thing according to the switch port here's the root bridge and this is my own information's 400 right and my own interface is the root port the e0 slash 2 is the root port and my all this two interface e0 slash 0 is alternate blocking 0 slash 1 0 slash 1 and 0 slash 0 is alternate blocking the reason the switch port put this interface into the blocking state just because of the lower sender port id because he's sending the bpdu and he's also sending the bpdu in this bpdu what happened he will put the ethernet 0 slash 3 is a port number and he'll put the ethernet 0 slash 2 is a port number so who has the lower one of course e0 slash 2 so this guy will be in the rp and this guy in the blocking lower sender port id so that's why the switch port make this interface as a blocking state all done let me do one more topology okay I'll do one thing I'm taking a very small one the two switches because I want to explain something over there so your port id concept will be clear and the cost concept. I will make this as a test 6, right? And we have just 2 ports. I'll call this guys 1 0/0, 2 0/0, 2, okay, not this one, 0/1, and 2 0/0, and I'll make this guy a 1, okay, 1 0/1, I'll make this guy 2 0/1. Just the mixture one. Okay, right? This looks good. Add it, switch 1, switch 2, and okay, we have switch 1, switch 2. Come on, switch 1, switch 2. What happened to you, man? What is the 6? Got it right? And why are you taking time? All right. Good. That's good. Test 6, and this is the safe position. And let me start this devices diagram. And here we have done. Now, of course, this will be a root one. I mean root bridge. This will be a non-root bridge. This will be a DP port. This will be a DP, right? Tell me who will be the blocking NRP.
D0/1 will be
Good port. And this will be the blocking. Okay, host name, country, host name, switch 1, spine tree mode, previously, and do the done. DZ, listening state, wait for some time, some more time. If you want to have the state in the debug command, you can use the debug span tree switch state, right? You can use this command to have a look how the interface is moving through the blocking, listening, and learning, right? We have seen this part in the last classes. I just have, if you want, you can do it. So DP, this is the root bridge, the switch one, of course. And if you have the look the switch to now, the root forwarding, right? It's 0/1. The reason is that because he's sending the BPD with the Ethernet 0/1, right? The port ID. He's sending the BPD with the Ethernet 0/0 is the port ID. I just want to show you this part, right? That port ID comes in the picture, lower sender port ID, not receiving part. So sorry. So not the receiving port ID. I want to show you over there, right? But if you see one thing, right, the cost is what? The tiebreaker. The cost is what? Tiebreaker. And cost always, do you know one thing? Though we have a two types of cost over there. One we have already discussed this part. So one we have a path cost, and second one we have a root path cost, right? Root path cost means what? The cost from non-root bridge to the root bridge. That is called as a root path cost. And the path cost is what? Interface cost is known as a path cost. That will be vary, right? That will be vary depend on the speed of the link, right? We have seen that if you have a look the close. Okay, 1 minute. Where's that? One, something somewhere else it will be there. Can you see that this one? The depend on the link bandwidth, we have 4 Mbps, 10 Mbps, 16 Mbps, 45, 100, and so on. The cost will be vary, right? This is cost, this is cost, so this is the link cost, interface cost, we can see that. This is the interface cost. So this is the cost that I'm going to define 100 over there. This is called what? This is called as a 100 cost as a path cost. But if I talk about, take example of this case, 100 is the interface cost, sorry, path cost. This is 100 path cost. But if I talk about from the switch port, hey, what is the cost from the root bridge? The cost will be 200. That will become the root path cost, right? From the non-root bridge to the root bridge. And the cost always comes in the path manipulation as well as, and lower cost, as we know that, always prefer, right? And the cost will be added at receiving point. Receiving point in the sense of what? Understand this part. This is a little logical. Switch one, switch two, switch three, switch four. We have this is the root bridge. So of course this is the DP, this is the RP, this is the DP, this is the RP, this is the DP, this is the RP, right? So take example, when this guy will send the BPD, right? In the cost, what will happen? 0. And the cost of this interface is a 4, 4, and 4. When this guy will send the BPD, the cost is what? 0. When this person will receive, right? When this person will receive, switch 2 will receive the BPD on this particular interface, they will add 0 plus 4. And now it will send what cost? The BPD 4. When this switch 3 will receive on this particular interface, they will add 4 plus 4, it will become the 8. Now when this guy will send the BPD to the switch 4, the cost is 8. This guy will receive and it plus for the 8 plus 4, right? So I'm adding what? The cost always will be added at receiving point, not the sending point. Can you see the sending is always 0? When the switch 2 is sending, it added the cost of the 4 over there. So cost always will be added at the receiving point, not on the sending point. What are the next point I want to discuss with you guys over there? The next thing is that what is the root path cost for the switch port? 12. So if the switch port wants to reach to the root bridge, the cost is what? 12, right? And cost always will be added at the receiving point. And which cost I'm adding? I'm adding the path cost, and that will be vary depend on the link bandwidth. Now understand one point. एक चीज मैं पढ़ा देता हूँ पहले को, उसके बाद अंडरस्टैंड करेंगे. Let me pause the recording, otherwise. Not this one. We can do any. No, those who continue never complete the port ID from the one switch to the port ID also you take care. Removing the parallel, so you change the local cost, you change the local port ID, and you change the local port ID will becomes the neighbor cost of this line. इसको मैं काम करता हूँ, copy करता हूँ and paste it on the asset पर when the local cost change, the local port you change the local port ID and becomes the this line. Okay. Take example. This link, right? This is the service provider. ISP. Of course, you can take a layer to connectivity from the service provider as well as you can take a layer to connectivity from the service provider as well. So this is my service provider ISP and this is my customer. And what I want, right? I want to switch the port rule. I want to make this guy a RP. I want to make this guy a blocking. And this is the requirement of what? This is the requirement of the customer. This is the requirement of the customer. How you will do that? When you're dealing with the parallel links, you change the local cost to change the local root port. So if you want to influence this part, right? I need to change my cost value because cost always will be added at the receiving point, right? Cost will be always added at the receiving point. So in that case, what happens if you go on a switch 2 and what I'm going to tell this person, hey, listen, the interface, the default cost is 100. I'll say that interface is 0/0 is spanning tree, okay, cost, which one? I'll make this guys a 10. It's fine. So spanning tree interface is 0/0 detail. The cost is added on there. 10. All clear? Because now the switch to, right, he cannot tell this person, hey, please change this port rule. Because take example, this was like 4 meg link, 4 mbps link, and this was a 2 mbps link. And just because of the spanning tree behavior, what happened? This guy will become the block port, right? And this is not a good solution because your 4 mbps link is block port and 2 mbps is working fine. So what I can tell this person, listen, I want to change this path. So I cannot tell the ISP, hey, do one thing, change from your side. They cannot do that. So you have to do from your side, and for your side, what happened? You need to change the cost. And now if you see the source spanning tree, what happened? Can you see the E0/0 is now become the root port? Previously it was blocking, now it will become the root port, and this blocking RP will become the blocking now. So in this case, you can change the cost, and cost always will be added at your receiving point. Right? Cost always will be added at receiving point. But if you want, right, if you want to change, let's take example, let me change this guy again. Let me make it default. Let me remove this guy. Okay, so now everything is normal. So do so is fine free. This guy has now moved in the alternate blocking, right? The same one. Now, for example, if you want to change this thing, right, from the ISP perspective, right, how ISP will do, it cannot change the cost, it will change the port ID, because lower sender port ID is there. Lower the cost will be added at the receiving point, and we have a lower sender port ID. So in this case, what happened? The switch one has to modify the port priority. How? Uh, I need to go take example. What is the default priority? Show interface. If you see, show spanning tree interface E0/1 detail. The default priority is what? 128, and this 2 is just a port identifier. So default priority is a 128. Lower is more preferred. So what I can do right now, this interface is a blocking. What I can do over there, this guy is a 128, and this guy also 128. I will change this guy. Interface E0/1 is spanning tree port priority. Make an increment of 64. Some on a some switches it will be a 32 as well as, right. Some switches, if you take example, do I have a command in the switch Cisco packet tracer. Some switches you will find the 16 or 32. I'm not 100% sure. Let me check it. So it's right. It will be vary depend on the model of switches. I think so. The command should be there. A spanning tree, on port priority. Okay. Link that is there. It's not. Also in the GNS3. GNS3 will have. And meanwhile, I'll show you the behavior. 1 minute, let me, because GNS3 will take some time to start the the devices and everything. So new blank project. And so I take the switch. Or then okay. So take some switch from there, and this is actually a switch, guys. So I'll just want to show you that this will be vary. So I'm not going to change the the icon. Leave it the icon default one, and just increase the putty size because this putty is very low. And here's session and default setting. 1 minute. 1 minute. 1 minute. Okay, default setting and save it. Yeah. Console. Wait for some time. All good. If you see enable and conflict on interface gate 0/0 spanning tree port priority. See, it's 32. So it will vary, right? 100%. It's depend on the platform. If this guy has a 64, can you see that? And what is the size of this guy? 224. And here I can define the 192. That's depend. I'll let you know why this is very, this point, why this point is very, I'll let you know. But this part, the increment, right, it will vary, depend on the platform. This thing you can manipulate. This thing you can manipulate, but this will be vary, depend on the platform. So you just need to first have a look like how the, what is the, like, the increment order is happening. Then in the, based on that basis, you know, change it. So now the default is what, 128, 128. What I'm going to do, make this guy, because I want to make this guy as a, right now, this is the blocking, right? I want to make this guy's RP. Right now, this is the blocking. I want to make this guy's RP and I want to make this guy's a blocking. So I need to do on the remote switches, right? Because you change the local port ID to influence the neighbor switches. So if I want to change this guy local port ID, it will influence on the neighbor switches. If I change the local port ID, it will influence on the neighbor switches. So I'll make this guy as a 64 is fine. I'll make it like it's not a big deal. So it's spine tree interface E0/1 and detail. You can have the port priority 64 now. And now if you see on a switch 2, previously E0/ was alternate blocking. Now what? It will root now. Did I manipulate the cost on this guy? No. I just, now he's sending the, like what? Now I have this guy's a 64 and this guy's a 128. So he's sending the port ID, the 64 port ID, and he's sending the 128. So what's recipient is going to do? So is to say, hey, this guy is the lower one. So I need to give the more preference to this guy, not to this guy. So priority first comes in the picture, then the port ID. Priority first comes in the picture, then the port ID. So the port ID is sent in the BPDU, sourced by the interface. It is 16-bit of field. Originally, the first 8-bit will define the priority, and the last 8-bit is going to define the interface number. So we can say like this, like, this is, okay. So this is like, the port. Okay, what happened to you, man? So this is your port ID concept, and here the port ID will going to divide into the two part. The first 8 bits is going to define the priority, and the second 8 bit is going to define the interface number. So 8 bit, 8 bit, total is a 16 bit. The priority is that we have manipulated. The interface number is what? This is the interface number, 0/0/19 in this guy, and this is the priority 128, 128. This limited number, right, of the ports on a switch 255 to increase the number of potential port on a switch. The field is now divided so that only the first 4 bits can be used for the priority, and the last 4 bit is a 12 bit is going to use for the interface number. So it's not like that it will be fixed that I show you this part, right? This one, it will be vary, right? It will be depend. You can manipulate depend on the requirement, the first 4 bit. But again, like, nobody will ask. I'll just show you that, yeah, this is the things that you can vary, right? But they only going to ask you like what is the size of port ID and what is the use of port ID. So you can see that, so making an election of, like, you can use the port ID concept for the manipulation of the spine tree topology as well. Guys, let me know if you have any questions now. I'm done for the today. Anyone has a questions? If I summarize the today class, what you will accept from the today class, you will only accept the cost concept, right, and the port ID concept, because the election of this, all this part we have already done in the first class, and how the manipulation is happening, this two one. If you not change the thing, you can change it. So by today agenda was only this two things, 2 and 3 things: the cost, port ID concept, and manipulation. Anyone has a questions?
Hello, not regarding to this issue, but I have a scenario.
Yeah,
Recently, I attended an interview, or the interviewer asked me that
yeah. Tell me.
there is a PC.
There is a PC. Okay.
Uh,
Should I pause the recording right now because I don't want to increase the time?